Verify the identity by transforming the left-hand side into the right-hand side. We have that the cotangent of the opposite of x divided by the cosecant of the opposite of x is equal to the cosine of x. Proof will begin by considering the left-hand side. So we have the cotangent of the opposite of x divided by the cosecant of the opposite of x. We can apply the identities for cotangent and cosecant. The cotangent of an angle is equal to the cosine of that angle, that's the opposite of x, over the sine of that angle. And the cosecant is the reciprocal of the sine of the angle. This first equation is true by the fundamental identities for both cotangent and cosecant. Now we can use algebra to manipulate things. We have a complex fraction here, and when we divide a fraction by a fraction, we can multiply by the reciprocal of the fraction in the denominator to give us cosine of the opposite of x over sine of the opposite of x, that's the numerator, times the reciprocal of the denominator, so times the sine of the opposite of x over 1, that's this part, it's the reciprocal of that part, and that's just by dividing fractions. We multiply by the reciprocal to do that. Now the sine of the opposite of x appears in the numerator and denominator, so it divides out to 1, leaving simply the cosine of the opposite of x. Now we're supposed to show this equals the cosine of x, and there's a bit of justification needed to conclude this proof. This is actually equal to the cosine of x. Now I suppose I should clarify the reason for this step before I go too far. This was simply by cancellation. And now why can I write this as just the cosine of x? Well, that's because cosine of x is an even function. Meaning, like any other even function, if I do the cosine of the opposite of x, I get the cosine of x. Now, this is almost just restating the identity that I'm, the step that I'm using, but it is based on prior knowledge about the cosine function being an even function. We can see, and this would conclude my proof, if there's a need to understand what it means for cosine to be even, I'm going to show you that next. Cosine is an even function because when you're on the unit circle, the cosine of the angle represents the x-coordinate of the point corresponding to the angle theta. If the angle theta is measured in the opposite direction, so rather than going positive, which means counterclockwise, we go negative, meaning clockwise direction, this will give us minus theta, then the x-coordinate stays the same. The y-coordinate is now the opposite of what it was before. Right? If this was our y value, then we're now below the x-axis, making it negative, but the x-coordinate is precisely the same, which shows that the cosine of theta, which is x, is the same as the cosine of the opposite of theta, which is still x. And that is what it means for cosine of x to be even. And that is the behind-the-scenes justification for this quick summary that simply says cosine is even, and so I can make this replacement and it's well justified. That does show that the left-hand side equals the right-hand side, and that concludes the proof.